Hello class. Today we're going to talk about solving inequalities. Yesterday we talked about writing them from a word problem setting and graphing those. Today we're going to solve the inequalities. Okay, so let's take a look at this warm-up. This is our warm-up from today. What I'd like for you to do is read each statement and write an inequality statement with that, and then we're going to graph it. So the first one says, there are less than 50 days to Thanksgiving. And that is a true statement because right now we've only got 43 days until Thanksgiving break. Okay, so yesterday I said the way we write this is we start with a variable. And this one I'm going to say Thanksgiving. Okay, and then we write our number. And now we have to determine the symbol that goes in the middle. We've got four symbols to choose from. We've got less than, greater than, less than or equal to, greater than or equal to, and those are the things that we're choosing from right now. Okay, there is one more inequality that we have worked with already, and that is the not equal to symbol. So in this one right here, it says that there are less than 50 days to Thanksgiving break. Well, when it says less than, that's kind of an easy one because it automatically tells you the symbol to use. T is less than 50. So if I asked you to graph that, we'd come over and do a quick graph, have a 50 there in the middle. And since it says just less than, that's going to give me an open circle on 50 because it's not going to include 50. And we're going to shade to the left because less than means to the left of. Number two, you can receive at most 100 on your assignment. Okay, so again, I choose G for grade. I'd put the 100 down. And now it says you can receive at most. So at most is the key right here. So that means the 100 is actually our top number. It is our maximum. So that means the G has to be smaller than that. Now your grade can be a 100. So that's why we put less than or equal to. So in this one, we'd come over to do a quick graph, put the 100 there in the middle. And this time we're going to have a closed circle because I can include the 100 and I shade to the left again. Okay, now yesterday we had some vocabulary words. Okay, there were inequality, algebraic inequality, and solution set. But there was a fourth one, and the fourth one that we had was a compound inequality. And compound is just like when we're using a sentence. A compound sentence is two sentences put together. A compound inequality, it can be two inequalities put together. So here's kind of an example of one of those. It says your grade can be between a 40 and 100. Now you can also have a 40 and 100, so we're going to include those. So the way you would graph a situation like this is you'd put a closed circle on 40, you'd put a closed circle on 100, and to represent all the grades that you could get, it's the ones that are in the middle. Okay, and the way we would actually represent that using an inequality statement is like this right here. 40 is less than or equal to G, and G is less than or equal to 100. So that G is in between those two numbers. And that is one example of a compound inequality. Now today what we're going to look at is how to solve one-step inequalities with add, subtract, and in the second half of the lesson, multiply, divide. So let's take a look. It says when you add or subtract the same number on both sides of an inequality, the resulting statement will be true. Take, for example, negative 2 is less than 5. Yes, that is a true statement. If I were to add 7 to both sides, I would end up with the statement of 5 is less than 12. That statement is also true. So what you find out with add, subtract is that to find the solution sets of inequalities, you do it the same way you find the solutions of equations. You isolate the variable. In other words, you add the opposite to get rid of your variable. So let's try a couple of these, and then we'll move to multiply and divide. So here we have this first one. Now, if this were an equation, we would have n minus 7 is equal to 15. So if you remember correctly, the first thing I asked you to do is change subtraction to addition, next number to its opposite, and then get the n by itself by adding the opposite. So we would do n plus negative 7 plus 7 is equal to 15 plus 7. So n is equal to 22. That's what we would do if this were an equation. But with an inequality, as you saw on the previous page, we solve them exactly the same way. So for this one, I would begin by changing my subtraction to addition next to its opposite. N plus negative 7 plus 7 is less than or equal to 15 plus 7. So n has to be less than or equal to 22. In the equation, on the right-hand side here, we have one solution and one solution only. n is equal to 22. But on the left, we have multiple solutions. So we have n is less than or equal to 22. So that means for values of n that are smaller than 22, this will make a true statement. So it's always important to go back and check to make sure that your solution is correct. So you come down here and you pick a value that is less than 22. So let's pick 20. Let's say n is equal to 20. So I'm going to come up and I'm going to plug in my 20 into my original equation. 20 minus 7, is that less than or equal to 15? Well, 20 minus 7 is 13, and that sure is less than or equal to 15. So always make sure you check your solution. Now, if I wanted to graph this solution right here, that's back to what we were doing yesterday. I would put a closed circle on 22, and it says I need to shade to the left. I need values less than 22 to make this correct. All right, let's try one more. Matter of fact, why don't you try this one on your own? So pause the video and work it for me. So let's see how you did. So in this one, I need to get d by itself, so I need to get rid of this plus 11. So we end up with d plus 11 plus negative 11 is greater than 6 plus negative 11. So again, we add the same thing to both sides. And we end up with d is greater than, and then 6 plus negative 11 gives us negative 5. So this says I need to pick a value greater than negative 5 to check to see if it works. So one of my favorite numbers to use when I can use it, when it's part of the solution set, is 0. 0 is greater than negative 5, so I can use 0 to check this answer. So I take 0 and I plug it into the original equation. 0 plus 11, is that greater than 6? 11 is greater than 6, so that is a true solution. Okay, so that is add, subtract. Now what about multiply, divide? Okay, so this is where there's going to be a snafu. So let's review what we do with equations real quick, and then we'll get to the inequalities. So if I had 4x is equal to negative 12, to get this x by itself, if I have a multiply by 4, we do a divide by 4 to get rid of it. And if I do it on one side, I have to do it on the other, and I end up with x is equal to negative 3. If I have a division problem, okay, to get rid of a divide by 5, I do a multiply by 5. So I do a multiply by 5 on the other side, and I end up with m is equal to positive 20. So on both of those, we have just a single solution. But now what about inequalities? Well, it said on that one slide earlier that we do them exactly the same way. So let's see if that works. So here I've got a multiply by 3. So I do a divide by 3, and I do a divide by 3 on the other side. We end up with x is greater than 5. So in order to check this, I need to pick a value that is greater than 5. So let's say 6. So I plug it back into the original equation. 3 times 6, is that greater than 15? Well, 3 times 6 is 18, and 18 is greater than 15, so that is a true solution. So to graph that, on a quick graph, we would just put the 5 there in the middle. I would do an open circle on 5 and shade to the right. Okay, does division work the same way? Well, let's see, I have a divide by 7, so we do a multiply by 7 on both sides, and we end up with r is less than or equal to negative 28. Now, to check a division problem, you have to be a little bit more creative, okay? So I need a value that is less than negative 28, but divisible by 7. Well, the first one that we have is negative 35. So if I were to plug in negative 35 divided by 7, is that less than or equal to negative 4? Well, negative 35 divided by 7 is negative 5, and negative 5 is less than or equal to negative 4. So that is a good solution set. Okay, so I would have the 28 here, the negative 28. I would put a closed circle on negative 28, and I would shade to the left. All right? Now, one of the things that we've done on every single problem is that we've checked our solution to make sure that it's make sure that it's correct. So what about this one? Pause the video and try this one on your own. Okay, let's see how you did. So more than likely, this is what you did. Okay, I've got to multiply by negative 5, so I do a divide by negative 5. and I do a divide by -5 on the other side. So you would end up with g is less than -4. Okay, and that's the solution that more than likely you came up with. But now let's check our solution just to make sure. This says I need a value that is less than -4 to check to see if it works. So I'm going to choose -5. So if I take that and plug it back into the original equation, that's -5 times -5 is less than 20. Well, -5 times -5 is positive 25. Is that less than 20? Oh, no, it's not. So that tells us that something's going on here. And what you have to understand about multiplying through or dividing through by a negative, it's going to flip the inequality as it goes across. Okay, so instead of this being g is less than -4, our answer is actually going to be g is greater than -4. An analogy that I like to use in class is, if you've ever been fishing, you know that the way you do that is you cast your line out and you begin reeling it in. Okay, and as that fish bites the hook, it's going to bite the hook and try to swim away from you as fast as it possibly can. But what you do as soon as that fish bites the hook is you set the hook. You pull on it real hard, and that sets that hook. And that hook has what we call a barb on it. And that barb sets into that fish, and it doesn't let it go away. So what you do is that fish is going away from you, you reel it in, and you flip it back towards you. So this negative acts kind of like that fish hook. It's going to set its hook into this inequality, and it's going to flip it as it goes across. That's only if you have a negative coefficient. Right? So really the way this problem should be worked is divide by -5, divide by -5. So g is not less than, but greater than -4. So if you pick a value greater than -4, 0. It's greater than -4. -5 times 0. Is that less than 20? Well, -5 times 0 is 0. And of course, 0 is less than 20. So for this particular problem, to graph it, you got the -4 right here. -4. We're going to put an open circle on -4, and we need to shade to the right. Because the value is greater than -4, we'll make this a true statement. Let's try one more. This one right here. Here we have a division problem. So I'm dividing by -3. So what I need to do to get rid of that is do a multiply by -3. And again, if this number is a negative, my inequality is going to flip as it comes across. We end up with c is greater than or equal to -18. So for values greater than -18, this will work. So let's try one. Again, 0 is found in my solution set. So 0 divided by -3, is that less than or equal to 6? Well, 0 divided by -3 is 0, and 0 is less than or equal to 6. So when you're multiplying and dividing, if you have a positive number, no problem. Okay, it just slides right on by. Right? But if you have a negative coefficient, your inequality will flip when you're solving. So that's how we add or subtract and multiply, divide inequalities. Until next time.